Hello, and thank you for joining me today. Today we'll be talking about polynomial functions. So let's get started with some definitions. A monomial is a number or a product of numbers and variables with whole number exponents. It is the simplest type of polynomial. A polynomial is a monomial or sum or difference of monomials. And a term is each individual monomial in the polynomial. A polynomial has no variables in the denominators, which means you're not going to see something like 1 over x. It has no variables in the exponents, which means you're not going to see anything like 2 to the x. It has no variables under a root or radical sign, so you're not going to see something like the square root of x. It has no variables with absolute values of variables, like the absolute value of x, and all the variables have whole number exponents. So you won't see something like x to the 2/3 power or x to the 0.3 repeating power. So to determine if you have a polynomial, you need to look at all of the variables. So here are some examples of polynomials and non-polynomials. The polynomials here have whole number exponents and numbers and variables. You could have a fraction as your coefficient as long as you have a whole number variable or whole number exponent on your variable. You can also have a decimal in front of your variable as long as it has a whole number exponent. So the examples below are not polynomials, and we're going to explain why. So this one has an x in the exponent. Now, that was reason number 2 for why it could not be a polynomial. So I'm just going to divide these up so we can write down which reason it is for each one of these. 4 over x has a variable in the denominator, so that is reason number 1. This one has a square root of x, and that is reason number 3. This one has, I don't know if you can see this very well, but it's a 0.456. That's not a whole number. That's reason number 5. And then finally, this one has absolute values. That's reason number 4, why it can't be a polynomial. Finding the degree of a polynomial is pretty easy. We're going to first add all of our exponents. So if we are dealing with just a monomial, one term, we're going to add all of the exponents together. So I see x squared, so we're going to do 2 plus y to the 7th, so 2 plus 7. And then the z, if it doesn't have an exponent, it's an implied 1. So z to the 1st power, we're going to add 1 more here. 2 plus 7 is 9, plus 1 is 10. So the degree of this monomial is 10. Now, if I look at the second one, I have x to the 1st power plus y to the 8th power plus z to the 7th power. 1 plus 8 is 9, plus 7 is 16. To find the degree of a polynomial, where it has more than one term, we need to find the degree of each monomial and choose the, I don't know why there's an S here, and choose the highest. So here I see I have 2 plus 7 plus 1, that was 10. 1 plus 8 was 9, plus 7 is 16. So the higher of these two numbers is 16. So the degree of the polynomial is 16. If I look at this one down here, I have 2 plus 9, that's 11. I'm just going to write that below. 15 and then 8 plus 8 is 16, so the degree of this one would be 16 as well. Now, we want to classify our polynomials by two things. We have degree and we have number of terms. So when we're classifying polynomials by degree, what we're going to be looking at is putting everything in standard form, which means all in order from highest exponent to lowest. So I'm going to write that here. All right, so that's what standard form means. Standard form is highest exponent to lowest. And as you can see in this example here, we have an x to the third, x squared, 1x, no x. So the degree of the polynomial is the highest degree, that's the biggest number. So we have several different ways to classify based on our degree. So if you have no variable at all and you just have a number, that's called a constant. If you have one variable with a degree of 1, like this 3x would be degree 1, then you would say that's linear. Degree 2 is quadratic. Degree 3 is cubic. Degree 4 is quartic. Degree 5 is quintic. And if a polynomial has degree of 6, you would refer to it as 6th degree polynomial, which would be anything higher than 6. You would just say it's whatever that number happens to be. So it could be the 73rd degree polynomial. It could be a 58th degree polynomial. So it doesn't matter what number it is. If it's higher than 6, or if it is 6, you just use that number. If I'm going by number of terms, polynomials with one term are called monomials. Polynomials with two terms are called binomials. With three terms, that's trinomials. And with 4 or more terms, you just call it a polynomial. All right, next we're going to add and subtract polynomials. The one thing that I would recommend that you do is I would recommend lining up, so I'm going to type this up, lining up terms based on their exponents. So we want this to be in standard form when we're adding, and we're going to line this up like a regular addition problem. So I see I have a second, a first, and 0 for my variables. So I'm going to line this up, negative 36x squared plus 6x minus 11. And then over here I can see I have a third power. So I'm going to put that farther over, 16x to the third. Then I see I have a positive 6x squared. And I have a negative 5, so I'm going to line that up with its like term. And then what I'm going to do is I'm going to add straight down. So if I add these straight down, I get 16x to the third minus 30x squared plus 6x, and then minus 16. So that is how I add these two together. Then, if I wanted to subtract, what I would do first is I would take this negative and I'd distribute it onto all three pieces here. So what I do is I'm changing this, which changes the sign of everything that's still in here. So now this is a negative 15x squared, a negative 3x squared, and then a positive 2. So I'm changing those signs first. Now I'm going to line them up by their exponents. So I have a 5x to the third, I have a 6x squared, and a 12. So I'm leaving space where an x term would be because I see that it's right here in my second equation. So I have a negative 15x squared, a negative 3x, and a positive 2. So when I add these again straight down, because I've changed all my signs, I've made this a plus, I get 5x to the third minus 9x squared minus 3x plus 14. before you do your You Try It problems, there is one change I need you to make with number 6. Number 6 says subtract the two polynomials, and then I was silly and I put a plus sign in there. I need you to change that to a minus. Okay, at this point I'd like you to pause your video and give these 6 a try. I'll come back in a minute and see how you did. All right, let's see how you did. The answers are now on your screen. This concludes our lesson. Thank you for joining me, and I look forward to seeing you in the next video.